All right, ladies and gentlemen, let's plug in some of these values here, and you can check your answer to see if you did this graph by yourself correctly. So plugging in -2, I get -2 squared, which is 4. But this is negative here, so this is -4 minus -2, which gives us -6, right? Notice that this negative is separate than the -2 here. -2 times -2 gives me +4. Times negative makes it -4. It's going to be the same thing with this -1. -1 times -1 gives us +1 times a negative is -1. So that's -3. This is -0 squared minus 2, which gives us -2. Plugging in +1 is going to give us the same result. 1 times 1 is 1. 1 times negative is -1, giving us -3. And when I plug in +2, I get -2 squared minus 2. Well, that's -4 minus 2, or -6. So -2, -6 is here. -1, -3 is here. 0, -2 is here. 1, -3 is here. And 2, -6 is there, creating a parabola that meets on the y-axis. There we go. So graphing parabolas by with a table, we plug in the points, we find the values, we plot them on the graph. Okay. Now let's talk a little bit more about things that we know in standard form. So standard form, as we said, is y equals ax squared plus bx plus c. All right. Now this graph, like we said, is going to form a parabola, right? And this parabola has a couple of very distinct points. Down here we have the vertex. And the vertex has a special relationship, okay? The value of x on the vertex can be determined by taking -b over 2a, meaning I take this value divided by 2 times this value. So the vertex can be found through a formula. We have another important point right here. This is the y-intercept, where it crosses the y-axis. The y-intercept is the c value. So this c value right here is the place where it crosses the y-axis. Now we have those same important points if our parabola was concave down. We have a vertex here that can be found by taking -b over 2a for the x value. We have the y-intercept here, which can be found by finding the c value. So let's go through and talk about a kind of method for graphing something in standard form. We can really do it in 5 steps. First of all, we want to identify the coefficients a, b, and c. So in our parabola, in our equation, what's the a value, what's the b value, what's the c value? We want to identify those things first. Then we want to find the vertex. And again, the vertex, we can use this formula, -b over 2a. To find the y value of that, we're going to take this formula and plug it into our function. Now we'll see that in just a second, okay? But we take this value and then we plug that value into our function. We are then going to draw in the axis of symmetry, okay? And the axis of symmetry is going to be at that same point where we find this, the -b over 2a. That's where that is. Then we're going to identify the y-intercept. That's our c value, right? Once we have those things down, we can draw a curved line. So let's go ahead and do these 5 steps together, okay? So here is my quadratic equation. 2x squared minus 8x plus 6. We want to first identify the a, b, and c values. So a, right? Remember, our formula is this. The a value is 2, the b value is -8, and the c value is 6. Step 2. Now we find the vertex. The vertex is found by taking -b over 2a. So we're going to take our values, -8, because that's my b, times 2, or divided by 2 over 2. 2 times 2, which is my a value. So this is +8 over 4, or 2. So my vertex starts with 2 for the x value, right? I know it's going to be over here somewhere. But to find the y value, I take this x and I plug it in for x in my equation up here. Y equals 2 times 2 squared minus 8 times 2 plus 6. So we figure this out. This is 2 times 4 minus 16 plus 6. This is 8 minus 16 plus 6, or 2. No, -2. Excuse me. So -2. So that is my vertex, 2, -2. And remember, this is either going to be the bottom of my parabola or the top of my parabola. My axis of symmetry is the -b over 2a. We found that value to be 2. So here is my axis of symmetry. Remember, parabolas are symmetrical. This dotted line that I just drew, we can fold the curve over it to find, and it would be the same on both sides. Now we need to put in the y-intercept. The y-intercept is the c value, which is 6. So I plot that point here. Now we've got this curved line that we can now draw. This is going to go up like this, something like that. Okay. Now, the fact that this is symmetrical is important because it means that I can take this side and it's going to be exactly the same over here. So since I'm going to the left twice and I'm crossing at 6, that means if I go to the right twice and up at 6, it will be the same thing. These are symmetrical, so they will curve up and down at the same rate. And there I'm done. So to review, we find the a, b, and c values. We plug in the b and the a into this formula to find the x value of the vertex. We then take the x value of the vertex and plug it into our function. We complete that to find the y value, plot the vertex. Draw in the axis of symmetry, which is a vertical line here at 2, or the -b over 2a. Then plot the y-intercept, which is our c value. Draw the curve, recognize that it is symmetrical and will therefore be at the same point on the other side, and curve the line up. All right, I've got one of these for you to practice on your canvas. Double check your notes, make sure you've really got this one, and then we can check the answers in the next video. So we'll see you in just a minute.